me. All right, this is from my other class, so we'll ignore this for now and get back to cisp440. All right, so first thing first, I'm going to talk about the exam first. I'll give you the solution or the answers to that test, and then we'll move on and talk about the birthday problem, which is, it's not a problem, it's a birthday calculation thing, which boils down to, given a number of people, what are the chances that no one within that group shares the same birthday? Okay, that seems pretty easy, right? I mean, if you have one person, then no one shares the same birthday. When you have two people, there's a pretty slim chance that those people may have the same birthday. And when you have 365 people, then there's no chance that no one shares the same birthday because you have just used up every single day of the year. Does that make any sense? So the question is, what about the numbers in between? Okay, what if you have a class of 20 people versus 30 versus 40? Okay, is that chance just kind of proportional to 20, 30, 40, or just the reciprocal of that, or what? Okay, so we'll talk about that after the review of the exam. Okay, but I'll plan that in your head right now so that you guys can kind of start to process that in the background. Okay, so here is the exam stuff. So what I'll do is I'm gonna, okay, so let's see. All of these are, okay, there we go. So I can import the PDF of one of the versions of that exam, and I put it into the share folder already. So if you go to the drive, you should be able to see it now. It's under cisp440, under shared. And let me refresh it. Ought to be here somewhere. I guess not yet. Okay, so there's a problem of synchronization, of this particular app with my Google Drive. So we'll fix that problem by going to the Google Drive first, go to the same folder, and then refresh this one first. A lot of Google products actually does not synchronize correctly. So it's right here. Let me show you which one. So it's right here now. So if you have your mobile device or your laptop computer, you should be able to access it now. So now let me switch back to the other app, and it's here now. So for some reason, the two apps seem to be sharing the directory, but this app itself cannot sync remotely with my Google Drive, but the other app can. So it's kind of like a two-step process. I have to sync the other one first so that this one can borrow, the directory from the other one. Not that it is actually of any importance to you. All right. Okay. All right, so since I'll be here for a little bit of time, I'm going to maximize this. There's no reason not to. And here are the 6 questions. There are variants of these questions. Okay, in other words, if this doesn't look like exactly the same as your exam, do not be alarmed, because for each question, except for I think one of them, there are 7 variants of each question. So whichever one you get is entirely based on a random number generator. So I think they're like all distinct in the class, if you talk about the combination of all the questions. So this is question 1 of 6, but the way to answer the question is the same. In other words, no one should be shortchanged. Nobody's getting an easy question in this class. Okay, so this question is asking you to give me the value of the expressions. In other words, evaluate the expressions and tell me what the values are. Okay? So we'll go ahead and look at the first one. And let's see, can I zoom in? Okay, let's zoom. Doesn't seem to let me zoom in any further. Can you guys read it if I were to write the answer? Okay. So the first one is A union B, which means everything in A as well as everything in B. But you have to be careful, do not list the same element twice, because in a set, all elements must be distinct or unique. So the way to do it is to repeat everything in A first. So we got 29, 8, 2, 6, 12, 9. The set of 12, 9. And then we look at B and we say, is there anything in B that is not in A? The answer is no. B is a proper subset, actually, of A. So that's our union. Is that okay? Now, if you recognize and say that, but this is the same thing as A, we don't need to list all of these things. If you just write down equals A, I will accept that as a 100% correct answer as well. Okay, spelled out is good. And, if you say it's A, that's good as well. Is that okay? All right. Second one. The second one is an intersection, which is basically things that are in A and B at the same time. So you have to look at A and B and go like, okay, what is common to both A and B? Well, that's pretty easy to tell, right? The entire set B is it. So the element 12 is in A and B. The element of 9 is also in A and B. So that would be the intersection. Are we good so far? So you can also say this is just A, and you can say this is just B. Okay, A is a subset of B. Okay, with the underline, it is not proper subset. It's just a subset, and the answer is no. There are plenty of things in A that are not in B, so A is not a subset of B. So the answer is false. Okay. So you can either say it is false, or you can say it's 0, okay, or even no. Okay, I will accept no as a very casual way of saying false. I mean, if you enter no in C and C++, it doesn't get highlighted because it's not exactly a value, a constant. What about B as a subset of A? Is everything in A in B? Well, let's take a look. B has 12 as a number. A has 12 as a number too. I'm talking about this 12 and not this 12. Okay? Same thing with 9. It is here. So we'll just say that, yep, B is definitely a subset of A. Yep.
Could you look at the subset of A or B? I could look at that set as 12 and 9 as the element, and it could be subset of B could be subset of A because of only that set, because it's like
So, okay, so let me answer the rest of the questions, because by the time I get to the last one, it'll be clear. Okay? But hold on to that question, because in case I do not answer that question, by the time we get to the last one, you can ask that. Okay, so what is in A but not in B? Well, there are quite a few things that are in A but not in B. 29, 8, 2, 6, and the set of 12 and 9 in it. All of these are in A but not in B. Okay? So the trick is, what I mean, 12 and 9 are clearly in B, so how come this one is actually in the difference? It's because the set of 12, 9 in it is not 12. The set of 12, 9 is not 9 either. And that's why it is considered different from 12 and 9. A set cannot be the same as a number. The bottom line is. The type is different.
So you would have to have like a double brackets. I mean, not brackets, like.
That would be correct. If I have another set of braces in B, then you can then 12, 9 would not be in the difference. But then the answers of the other ones would change as well. Well, except for the subset one, because it will still be a subset. Okay, what about in? A is an element of B. That's pretty clear. One is like, and the other one is like this. So the answer is no, okay, or false. And then the last one is B an element of A? And the answer is true. This is probably the trickiest one, okay? The last one is the trickiest. So are we okay with question number 1 of 6? Are there any questions regarding that one? Okay. So what I'll be grading on is also making sure that you use curly braces to enclose things that are in a set, because that is actually important. Okay, so if somebody gives me just a list but without the curly braces, some points will be deducted. Not major, but there will be some points deducted. All right. So moving on to question number 2. You are given that x equals to 4, 20, 8, 28, 24, and 19. You're also told that this is a subset of R. Okay, so the set of the two tuples, 19, 20 as one tuple, 4, 28 as another tuple. That set is a subset of R. And I wrote on the whiteboard that R is a relation defined over X. Okay, for this question and also for one of the other questions. Okay, so you're also told that R as a relation is reflexive and symmetric. So the first step is to indicate whether such a relation R is possible. If so, present an example in the form of R equals to a set, and then you tell me what elements are in the set. If not, explain why it is not possible. Okay, so the answer is yes, it is possible. Okay, this is a constraint only. In other words, I'm only saying that 1920 has to be an element of R. I'm also just saying that 428 has to be an element in R. Can we have additional elements in R? Absolutely. But can R only be these two? Well, yes, based on this constraint, but the other constraints of R being reflexive and symmetric means that your R has to be bigger than this. Okay, so now the answer is yes. Okay, so you have to clearly indicate yes first, and then you have to say, okay, but what is in R to make this work? So R in this case, because it has to be reflexive, which means every element in X has to relate to itself. Very good. So we have 4, 4, 20, 20, 28, 28, 24, 24. So these are pretty usual. 19, 19. That makes R reflexive. Okay, but since we know this is a subset, 1920, 428 is a subset of R, we also know that that has to be in R too. So you can copy those elements for sure. So you can now copy 1920, 428 into R. But that would make R not symmetric at this point. Okay? Why is it not symmetric? What is symmetry? For all ways to find AB in X, okay, AB as a two-tuple is in R if and only if BA as a two-tuple is also in R. Okay? So right now it is not symmetric because 1920 is in R, but 2019 is not. So, but since we have the freedom to specify the content of R, we can just add to it. So we can now just say 2019 is going to be there, as well as 28, 4. Okay? Can I just keep adding pairs of random elements? Absolutely. But why would I when I'm running out of time? In other words, this set is the minimum to make R meet all the requirements, all the constraints. Okay? But if somebody says, hey, I'm just going to add, I don't know, 28, 24 as one tuple, 24, 28 as the other tuple and put it into R, R still meets all the requirements. This question does not ask for a minimal relation. It just asks for a relation R that meets all the requirements. Is that okay? Is that good? All right. So that's question number 2. Question number 3. Okay. So question number 3 is kind of has this. It just wants to make sure that you understand those terms. What is injective, what is surjective, and so on. So the constraints are, I give you D. You cannot change D because it's a given. So D has the following elements: 2, 11, 15, and 20 in this particular question. And I also tell you what is already in F. 215 has to be an element in F. 2020 also has to be an element in F. Okay? And what is this telling you? F colon D and then a right arrow to E. What does that mean? What is that notation saying? Yep. Yep. But in order to use the term domain and codomain, F is a function. So this is confirming that F is a function, D is the domain, and E is the codomain of that function. Okay? So in the following space, define F and E as sets based on the stated constraints. So the stated constraints would be what D is, what is a subset of F. F is a function mapping the domain D to the codomain E. Those are the constraints. But other than these constraints, you are free to define F as a set as well as E as a set any way you want, as long as it meets these constraints as well as these constraints. So there are 4 sets that you have to generate. So we'll work with the first one first. Okay, so in this case, let me back up a little bit. Let's define E first. Okay, because with this one, we are saying F is injective and surjective, which makes it bijective. Okay, so if E has to be bijective, what are we going to do with that? So what has to be in E? Okay, that's the easy part. What has to be in E is easy because we know from F itself that 15 and 20, they have to be in E for all of the questions. Does that make sense? Because 2 is mapped to 15 in function F, and E is the codomain of function F, so that means 15 has to be in the codomain E. Same thing applies to 20. So those 2 we know for sure. So E has to start with 15 and 20, and it's the same for all of the other questions. Now we don't know what else, okay? E can have or must have, but we know that much. Okay. But back to the first one. Because F has to be injective and surjective, what do you think is going to be the cardinality of E? Huh? It has to be the same cardinality of D and also F. D and F are the same, they have the same cardinality to begin with, but now E also has to meet that constraint. Okay? So we need 2 more things in it. Well, I don't say that those 2 things must be coming from D. It can be something else, right? So you can have A, B in it, or and something that is not even in D. That's perfectly okay. So I'm just going to use A, B to emphasize that you can have anything in E. Doesn't have to be the same thing that you already have in D. So now the question is, how do I make F to also meet that requirement? Now, what F must have, okay, curly braces here, would be the 2 things that are known to be in the subset of F. So 215, 2020, I don't have a choice. Those 2 must be in F already. But I also have to map the other 2 elements. In this case, the elements would be 11 and 15. So they also have to map to something in the codomain. And on top of that, because it is both injective and surjective, they have to map to different things. in the codomain. So that means, now this part is arbitrary, so I can pick 11 to map to A, and I can pick 15 to map to B. So now this meets all the requirements. Does it have to be 11 to A? Can 11 map to B and then 15 map to A? Yeah, perfectly okay. Instead of A and B, can we have an MX5 and a MR2? Yeah, sure. There's no constraint of what other elements you can add to the set. Now, I know some of you are really tricky and want to demonstrate that, yes, I really get all the concepts in this class. Then you can have the empty set in place of A, and then the set containing the empty set as B. That's perfectly okay too. If you want to convince me, Tech, I really get this material, I really understand a set can be an element of another set, be my guest. I'm perfectly okay with that. Because it's not offensive at all. Is that okay? Does everybody get the first part? Okay, the second part. F is injective, but it is not surjective. Well, that means everything has to map to a unique element. Okay, everything from D has to map to something unique in E, but then something in E is not mapped to at all. Well, that's not too difficult, because what we can do now is just to say, well, let's add C to it. Okay? Now, if you're running out of time, you can just say this. F can be defined exactly the same way as before, as the first question. We just say that, oh, by the way, we now have one extra element in the codomain C that nobody maps to. That would be a perfectly okay answer. Is that okay? Okay, what about the next one? F is not surjective, but F is not injective, but it is surjective. So that means everything has to be used up in the codomain, but things from the domain do not map to unique things in the codomain. Well, that's actually easier than the other ones. We just say that's it. That's all we have. Okay? And then F can have the two things that must be in it. 2 maps to 15, 20 maps to 20. And then we can have the other two map to 15 in this case. Okay, it's not important how these two are mapped, as long as it's something in the codomain. Is that okay with the third one? Last one. F is not injective, and it is also not surjective. You just add one more thing into the codomain that nobody maps to, okay? And keep the function as in the third one. Because in the third one, it is already not surjective, okay? If you do not map if you do not change the mapping of elements, something that is not injective will still be not injective. But you just have to make sure that there are things in E that are not mapped to. Well, we just add one more thing in E, but keep F the way that it was from the previous question, from the previous sub-question. Is that okay? So any points, anything you want to discuss with number 3 of 6? Were you guys as lazy as I was? Just say, we'll just copy the previous one and add one more thing to E. Yep, that would be the way to do it. But that really illustrates that you also understand the relationship between injectiveness and surjectiveness, is to spot and go like, oh, this is really the same thing as the one before. We just have to change one little minor thing. Okay, question number 4 of 6. Okay, So let's read the question first. Assume R is defined over the set of all positive integers, and Z plus is how I refer to the set of all positive integers, such that for all xy, for every way that you can pick out two elements from the set of all positive integers, x mod y equals to 0 if and only if xy is in R. Okay? What is that saying? What is that saying about R? xry really means x is a multiple of y. The other way to say it is to say that y is a factor of x. Is that okay? All right, so now that we know that xry really is just saying x is a multiple of y, oh, I said that too. So there's no need to actually parse the mathematical symbols in this case, because I summarized myself and say that, in other words, x or y if and only if x is a multiple of y. Spell out the membership of the set in this notation: 30 e in a two tuple bar 30 comma e in 30 comma e in a two tuple is an element of R. In other words, give me a subset of all the elements in R that starts with 30 as the first element. It's the first item in a two tuple. Tell me again what kind of things would start with 30 in R. All the relations describing 30 is a multiple of E. Okay? All right. So to answer that part, just to answer what S is, okay? So the first one is 30, 30. Now your ordering can be opposite to mine, but either way is systematic. Is 30 a multiple of 30? Yep. Okay. So now next one is 30, 15, 36, 35, and then 32. Oops, 3 first, because we want to make it systematic. And then the last one is 31. Okay, so that's S.
You have 30, 10 in there?
Yep, thank you. I missed one. So that would be here, 30, 10. Okay. So in your particular question, it can be different, but I made sure that every single question, the number that I choose here is the product of 3 distinct prime numbers. So it has to be 3 numbers chosen from the set of 2, 3, 5, 7. So the worst case it can get is 7 times 5 times 3. This is the easiest one because it's 2 times 3 plus times 5. But in terms of spelling out all the elements, all the answers should have the same number of elements. All right. So, but this part of the exercise is really to give you an idea of what is in the set R itself, okay, to help you answer the other questions, okay? So now we want to answer the question of, is R reflexive? R is reflexive. Okay, so the answer is yes, but why is it reflexive? Because any number mod itself is 0. Okay, so you can just say that, x mod x is always equal to 0. Or in one way or another express that, okay? Is R symmetric? The answer is no, it is not symmetric. Now, how does the example illustrate that R is reflexive? That guy. Okay, it's giving you a clue of like, maybe elements are relating to itself. But how come we think that it is not symmetric? Because it is a multiple of, okay? If A is a multiple of B, does it automatically mean that B is a multiple of A? Okay, So to show that it is not the case, you only have to show me an example. Okay, so give me an example where A is a multiple of B, but B is not a multiple of A. Choose any one of those. Pick one. 31, okay? The most extreme case, right? So you can say 30 mod 1 is 0, but 1 mod 30 is 1. Okay? So any way you can explain that, any counter example would work. Is R antisymmetric? Now, what is antisymmetric as a relation? ARB and BRA implies A equals to B. Right? So in this case, does that hold? 30R30 and 30R30 implies 30R30. Okay, so the example does show that it is promising. Can we show any counterexample? In other words, okay, what is a counterexample in this case? So I will get back to this one. I'm just opening up a new sheet to explain the counterexample. Okay, so the original statement says, for all A, B in X, A, RB, and BRA implies A equals B. That is the requirement of anti-symmetric. Okay? It's just copied straight from the notes. Okay. So what is the counter of this? In other words, what is the negation of that? So let's check out what is the negation. So the negation says, okay, so we'll do it step by step. And we can't really work on the negation until we are done with changing the implication to a not and or. So we'll do that first. That's just using the definition of implication. And then we look at this and go like, that's still a little bit hard to understand. Let's apply De Morgan's law. So once you apply De Morgan's law, then you're applying A, not ARB, or not ARB, or A equals B. Okay? But we have a final negation on the outside, so we have to apply one final De Morgan's law that says not ARB and not BRA and not A equals B. But that simplifies to ARB and BRA and A does not equal to B. So can we find one example that meets the requirement of the counterexample? Because this is the negation of what the definition has inside the parentheses. So that means if you can find me a pair of A and B to make this true, ARB and BRA and A does not equal to B, then you have just proven that R in this case is not antisymmetric. Can we find an example like that? And the answer is no. Okay? The answer is no, you cannot find a counterexample. Why can't you find a counterexample? Well, it is possible that you have ARB and BRA, but then A and B must be the same thing to make that happen. So that contradicts the last one.
But other than 30-30,
Mm-hmm.
there's no BRA.
Correct. Yep. Yep. So that means the answer is yes, it is antisymmetric. All right, so let's go back to the question so I can put it there.
30-30 is 30 times 10 to the 6 plus 1 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 times 10 to
So the answer is yes, it is antisymmetric. And then you can just write down, A mod B equals to 0 and B mod A equals to 0 does imply A and B are the same. Okay. Is R transitive? The example should actually illustrate that it probably has a likelihood of being transitive. Okay, even though it's not listed everything, it's not listing everything here. Just because of my own omission, that gives you a clue already. What did I omit again? It's pretty obvious. I omitted one earlier, and then you help me fix that one and go like, yeah, you're missing one. I'm missing this one, right? So if you think about it, 30 is a multiple of 10. Is 10 a multiple of something other than itself or even 1? Yeah, it's a multiple of itself, 5, 2, and also 1. Okay, so if 10 is a multiple of 5, 2, and 1, is 30 also a multiple of 5, 2, and 1? 5, 2, and 1. So we have very clear evidence that it is transitive. So let's say yes first. But why is it transitive? I mean, you can explain it, in a variety of ways. Okay, so you can say if P1 equals A times B, and P2 equals A, B, and C, then A, let me try to use P2R P1 and P1R A. You can pick B, you can pick C, it doesn't matter. Is that okay? I mean, yes? Okay. Next one. Is R partially ordered? If you look at the list of things, the answer to which we say yes, okay, does that answer all the questions that you need for something to be partially ordered? Yes, it is partially ordered. It is reflexive, antisymmetric, and transitive at the same time, so it is partially ordered. And the reasoning of this one is actually the easiest of all of them. Okay, so the answer is yes, because it is reflexive, antisymmetric, and it is also transitive. That's all you need to say that something is partially ordered. But is it totally ordered? What is the one difference between totally ordered and partially ordered? How do you describe that? It's in the notes, okay, in the form of a mathematical expression, but how do you explain it in words? Everything has to relate to everything has to relate to everything else. The direction doesn't really matter, okay, but they have to relate to something else. Okay, so show me something a particular integer does not relate to another integer at all. Neither is a factor of the other. That's what you're looking for. We have plenty of examples. Show me one. How about 5 and 6, 2 and 3? Okay, so you can just say no, okay, because 2R3 is not in R, and 3R2 it's also not in R. And that's it. That basically make it impossible to meet the extra requirement on top of being partially ordered to become totally ordered. Is that okay? All right. Okay. Moving on. Yep.
On problem 2, actually.
Hmm?
On problem 2,
On problem 2.
did you define it as the Cartesian product of x and itself?
Yeah, that would meet the requirement. Wait,
Says 3.
or question number 2.
Yeah.
Okay. Because I was looking and go like, no, that's not it. Okay, so say that one more time.
Could you define R as the entire Cartesian product of X in itself?
Yes,
Okay.
that would meet the requirements. Yes, and not really have to write a whole lot. Yes. So if you say, R is the Cartesian product of X versus X, then it also meets all of these requirements. Yep. Okay. So number 5. You know that I have to ask one question about function g, right? Okay, so in this case, g maps, the Cartesian product of natural number and natural number to natural numbers, which you already know, is defined as it is defined in the Aleph No module. Show that blah 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 blah. Okay, so so what is it asking you to show? It's asking you to show that um, if x1 does not equal to x2 or y1 does not equal to y2, then the g values of x1, y1 cannot be the same as the g value of x2, y2. That's basically what it's asking you to show. So how do you approach this? Well, everything has to boil down back to the equation, right? So how many individual cases do we have to show here? Sorry? 4? Okay. Okay. So you have to look at the or and say, how can we make the or true? Okay. So the only time the or is false, which means it is none of our concern, is when x equals x, x1 equals x2, and y1 equals y2. That's the only case that we do not have to handle. And then for the other 3 cases, we kind of have to think about those, and 2 of those are symmetric. Okay. So what we'll need to do is to say, okay, let's break it up into 3 cases. Okay, the first one is x1 does not equal to y2, x1 does not equal to x2, and y1 does equal to y2. The second one is x1 does equal to x2, and y1 does not equal to y2. And then the third one is both. Okay, x1 does not equal to x2, and y1 does not equal to y2. Okay, so we have 3 distinct cases that we have to look into. Okay, so we look at this one and we say, okay, let's look at how the g values are going to be expanded. Okay, and then we basically have to simplify x out of the whole thing and then go like, oh, okay, so the 2 sides have to be different. And it's going to be the same for all of these. Okay, so we have to show that x1 plus y1 times x1 plus y1 plus 1, the whole thing divided by 2 plus y1 has to be different from x2 plus y1 again, because x2, y2, x1 and y, x1 and y2, no, y1 and y2 are the same. Okay, there we go. x2 plus y1 plus 1, the whole thing divided by 2 plus y1. Okay. These 2 cancel out, right? And then you expand out the multiplication. What do you end up with? Well, something that's kind of long. Okay, so you end up with x2 squared plus, okay, I'm just counting the number of things here. Well, we can always just do it this way. So we have 1 x2 y1 plus x2 plus y1 x2 plus y1 squared plus y1 divided by 2 has to be different from x1 squared plus x1 y1 plus x1 plus y1 x1 plus y1 squared divided by 2. And then certain things will cancel out. The y1 squared will cancel out. And I think I'm missing 1 plus y1 in the end. Okay. So we can do it in an algebra way, which is kind of long, painful. What is the other way to answer this question? I can think of a kind of verbal explanation. So what is the verbal explanation of just this part? We are looking at two different pixels in a 2D space. Okay? So if you're looking at two different pixels in the two-dimensional space, how do we guarantee that they do not end up with the same value? How do we assign the values again? We go with the diagonals, right? So there are only two cases left. They're either in the same diagonal or they're not in the same diagonal. If they're in the same diagonal, they cannot have the same value because the y is different, and that's what makes the g value different of everything in the same diagonal. If they're in a different diagonal, then why do we know the g value would be different? Because x plus y would be different between those two. So if you look at x plus y itself being different, y alone cannot make up for that difference. So there's no way the y component can make up for the difference of x plus y as a sum being different, because that term is squared. Did anyone just explain it, just saying that, because of the way we fill in the numbers, that they cannot be the same? No one? Okay. How did you guys answer this question? Sorry? Kind of like that? Okay. Did anyone try to... Yeah, go ahead.
As I answered it a couple ways, but I also remember that you mentioned in the module that the function's bijective, which means that the implication has to be true.
You can do that too. Yep. You can definitely use the bijective property, because if it is bijective, then this is saying that it is not bijective. Yep. So you can definitely use the function being bijective to explain this. You don't even need the whole bijective. Just injective is enough. Just because G is injective, this has to be, we know that this property has to hold true, just because it's injective. Yep.
I said that because it's natural numbers, so you can't have it complete.
Mm-hmm.
That x1 plus y1 has to be equal to x2 plus y2. Is what I said for the overall form to be true. That's if you're choosing different y's, then I think I was saying like that x1 has to be equal to y2, or I don't know what I said. Just something like that. But I said that the x1 plus y1 has to be equal to x2 plus y2.
Mm-hmm.
For the g of x1 and y1 and g of x2 and y2 to be equal, then the only time that would be true, your y's are going to be different, so the overall answer, your g answers are going to be different by the absolute power of y2 plus y1.
Okay, I can follow that.
And then I put in like a couple other like cases or whatever that it could be.
Mm-hmm.
And that was my overall
Okay.
statement.
Yep. So there's a variety of way to show this one. You can either do the whole algebra thing. You can use the way of number being assigned to the squares in the two-dimensional space. You can utilize the fact that in the notes, because it does say here, as defined in the Aleph node module, you can use the Aleph node module and say that, well, according to that module, G is bijective, which means it is injective. If it is injective, then two different elements from the domain must map to two different elements in the codomain. And that's basically the end of that proof. So there's a variety of ways to prove this particular one. Okay, any way you feel is logically connecting and based on logic, okay, is fine. Is that okay? All right. So I'm at the same time looking forward and not looking forward to grading number 5. Then the looking forward part is out of curiosity. The not so looking forward to is, it will be very difficult to assign partial credit or even have a grading scheme. Because I like grading schemes that are kind of black and white. I can just say, yep, and check. So that one is kind of open-ended. Let's look at question number 6. Assume X is 3, 7, 13, 19, and 20. And then we have the 3 elements, 19, 7, 7, 3, 3, 13, as a subset of R. Define R in a minimal fashion. So this time it has to be minimum. So that R is anti-symmetric and it is also transitive. And your answer should be in the form of R equals 2, and then you list the elements in it. Okay. So you look at this one and go like, how do you approach that? Now this time it has to be minimum, so having that Cartesian product is not going to work. And the Cartesian product would not work in this case anyway, because any type of Cartesian product, except for the trivial case when X is either empty or only has one single element, maybe even with 2 elements too, is not going to be anti-symmetric. So in general, the cross product or the Cartesian product of X with itself as a relation is not anti-symmetric. Because you will find A or B, you will find B or A, because it is the Cartesian product. Everybody relates to everybody else. But does A equal to B? No. Okay? So that's why you cannot use a Cartesian product in this case. All right, so let's go ahead and show what is going to be in R. Well, we know 3 things have to be in R, don't we? Because we know that set that is listed here is a subset of R, which means everything in there we have to copy. So we just say 19, 7, 7, 3, 3, 13. They have to be in R. So we'll deal with transitive first, okay? So now we have to deal with transitive, which means if there's a bridge element, okay, it is the second of the first tuple and the first of the second tuple, then we should be able to quote-unquote concatenate with the bridge element removed. So that means 19,3 should be in the set. Because in that case, we are using 7 as a bridge element. So 19,3 should be in the set. And we can also use 3 as a bridge element. And when we use 3 as a bridge element, then it's bridging 7 and 13. So we know that 7 and 13 should be in the set as well. Okay? But if we use 7 as a bridge element, then we can connect 19 and 13 together. So that means 19, 13 should also be in the set. So 19, 13 is also in the set. Now there are 2 ways to bridge from 19 to 13. You can bridge it through 7. Let's see, there's another way to bridge it. You can bridge it through 3 as well. Because 19 to 3, 3 to 13, that's one way. And then the second way is 19 to 7, and then 7 to 13. But you only want to list 19, 13 once, because this is in a set. Okay? So you look at this, because the question does ask what is the minimal set that can be both anti-symmetric and transitive. So the question is it anti-symmetric at this point? Once again, what is anti-symmetric? Antisymmetric is for all ways to pick two elements out of X. A are B and B are A implies A and B are the same. So the question is that expression true as it is now? Because if the set is already anti-symmetric, I'll just close the curly brace and be done with it. So the question is, well, is that true? For every way to pick out A and B in X, can we first of all make this conjunction true? The answer is no. We cannot even make that conjunction true, right? Because if you look at, the relations that we have defined at this point, it's one or the other. We never really have ARB and BRA both being true. But that's good news, isn't it? Because if you cannot make the conjunction true, that means the left-hand side of the implication is false all the time. If the left-hand side of an implication is false, what happens to the value of the implication itself? True. Oh, so that means we're good now. You just close the curly brace and you're done. So this is, in fact, the only answer, because in this case, the question is asking for a minimal fashion. So this is the minimum. You can add additional elements to R. It can still be transitive and antisymmetric, but it wouldn't be the minimum anymore. This is the minimum. So is that okay? Question?
Is this one like randomly generated too?
Yes.
So is there a possible case where you only have one like bridge number?
One bridge number.
Yeah. So I'm trying to think if I mess up. Or if I just have one bridge number.
Okay, so if I only have one bridge number, that means
you get 7 and 3 as bridge numbers in this problem. Because you have 19, 7, 7.
yeah. Mm-hmm.
So you had 2 bridge numbers. I'm thinking on my problem I have 1 bridge number. Is that possible?
Yes, it might be. If you have one bridge number, that means your answer is even shorter.
Yeah. Okay.
So I'm hoping you're not complaining.
No. I was just like, I wonder if I forgot. Like I didn't notice.
No, but I guarantee that they're all like this. But there may be a variance of 1 to 2. I mean 2 to 3 in the subset. But the concept is still the same. Okay, you still have to kind of show me what transitive means and what antisymmetric means. So are we good so far with this? All 6 questions? Okay, if you do have any questions, just ask me anytime you have those questions. And then meanwhile, we're gonna number 2. Number 2 is popular. Two. Oh, the curly brace? Oh, this is the open curly brace. Yeah. Yeah, poor penmanship. Yeah. Yeah, poor penmanship on my part. There's a little squiggly thing on top of the 2. That's why I wanted to zoom in first, because that gives me a little bit better control over the pen. Yep. So is that it? Okay. So I explained this one with poor penmanship. Any other questions? Yes. Number 4. Okay. All right. So here's number 4. And which subpart do you want to talk about? You mean here? Well, okay. Only the subset as, only the 2 tuples in subset S has to start with the value 30. But the question is asking about R, not about S. Yeah, the construction of S is to give you an idea of what kind of elements is in R. Is that okay? Okay, cool. All right. Yep.
When are you gonna grade these tests?
When I have time. And this is a class of 50 on the day of the test. All right. So shall we move on to the birthday question? Yes? All right. Okay. So I'm going to close this for now. And again, if you have questions, always ask those questions. I can get back to this. But for now, we're going to go and talk about the birthday question. And it is actually in the notes too, so you can actually find my notes or a spreadsheet to talk about it. So what we'll do is to talk about the birthday question, and I will post the question first. So I'm going to post the question of, given n people, what are the chances that no one shares a birthday? In other words, no two people of the n people share the same birthday. All n people have distinct birthdays in this case. Is that okay? All right? So what do you think? How do we approach this problem? How do we start thinking about it? Go ahead. Uh-huh.
So you take n divided by 360. No, no, no. Okay. Let's say.
I like your line of reasoning.
And then obviously we need to use a 360 in there.
Yeah, 365 is in it, and n is in it too because we have n people, and then we have 365 days to choose from, right? So I need to find out how many unique ways I can pick out n days out of 365, but ordering is it important or not? Okay, so that becomes the question. We know it has something to do with choosing. Okay, we talked about permutations and combinations already, and both of those have to do with how many ways can we, pick out, this number of things from that number of things. Okay, the only difference between combination versus permutation is in combination, duplicates, okay, having things sequenced differently are considered the same. Whereas in permutation, 1, 2, 3 and 3, 2, 1 are distinct. They do not count as one. Okay? So now the question is, how do we look at this problem from that perspective? So when you have questions like that, the first thing you do is to make it simple. In other words, instead of looking at an abstract thing like n and a huge number like 365, you just say, well, how many, well, 365 is not a big problem, but the n is, okay? So think about a very small class, okay? Let's say 3 people, okay? And you only limit yourself to maybe 5 different days, okay? So let's say you're only concerned, there are only 5 legitimate days that people can choose from. So we have April 1st. We have, I'm going to pick some really odd days, okay? So we'll have February 29th. Give me some other funny days that people may not want their birthdays to be on. Maybe May 13th. Any other days that you do not want to have your birthday on? Huh? Halloween is not on a particular set day, so that makes it kind of difficult. But we'll throw that in, okay? Halloween. How do you spell Halloween? H-A, right?
It's October 31st.
Huh?
It's October 31st. October 31st.
October 31st. Why is that a bad day?
That's Halloween. That's Halloween.
Huh?
That's Halloween.
That's Halloween? Oh, okay. Obviously, I have not been trick-or-treating for a while. Nor giving treats. Okay, so let's pick one more day. Yep. November. And why is that a bad day?
That's Black Friday.
Oh, okay. Black Friday. But that depends on the year too. But we'll pick it. Okay. So we'll say November 23rd. Okay. So let's also say that there are only 3 people in the class. Okay. So let's pick some gender neutral names. So we'll have Pat for obvious reasons. Give me some other gender neutral names. Huh?
We're gonna start rhyming here.
Go ahead. Huh?
Matt.
Matt? But Matt is not gender neutral.
Danny.
Hmm?
Danny.
Danny?
Yeah, it's a gender.
Maybe. Danny?
Yeah, like a girl called Danny.
Okay.
Alex. Short. Alex.
Alex?
Like this. That's not that.
Alexandra? Right? Okay, we'll pick those 3. All right, fine. So now we got 3 names, 3 people, and let's just say that they can only pick one of these 5 days. Okay, so the question is, how many distinct ways can these 3 people pick unique dates out of these 5? Now that suddenly becomes doable, right? If this is doable by just saying, oh, okay, Pat can pick this, blah 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 blah, and so on. Okay, so how many ways can this be done? So, but remember, the main question is not that this is a 5 out of 5 pick 3 kind of problem. We kind of know it is either permutation of 5 permutation 3 or 5 combination 3. We know it's one of those 2. The question is, which one is it? Okay, so now we just say that, okay, let's consider this case. Pat picks April 1st. Danny picks October 31st. And Alex picks November 23rd. Okay, that's one way to pick 3 different unique dates. Is that okay? And then we look at another way of picking and say, what if Pat picks October 31st, Danny picks November 23rd, and Alex picks April 1st. Are these 2 the same or not? Do we consider these 2 the same? They are not the same. So are we dealing with permutations or are we dealing with combinations? We're dealing with permutations. Okay, we're dealing with permutations because ordering is important. So you can basically forget about the names. Okay, forget Pat, Danny, and Alex. You just look at the ordering of the dates. April 1st, October 31st, November 23rd is considered different from October 31st, then November 23rd, then April 1st. So ordering is important because we are implicitly placing people in a particular order. Okay? Okay, so now that we understand it is a permutation issue, okay? So now we say, okay, so it's a permutation kind of thing. I'm going to use the P to stand for permutation for now. How many things do we pick from? Available. No, in the case of the original problem. 365, okay? So we have 365 days to choose from, and we have n people in the class. So this is the number of ways we can assign n unique days to people. There are n people, each one is picking a unique day in a year. Is that okay? All right, so that answers one half of the question, because the question was, what are the chances, right? So that means we have to consider all possible ways of picking days from 365 for n people. And what would that look like? In other words, the entire class can have the same birthday. Half the class can have one birthday, half the class can have another birthday. So how do I figure this problem out? So I'm just going to randomly call out people here, okay? So it's basically the same thing as, okay, you pick one day of the whole year. You pick one day of the whole year, but it has no relation whatsoever to what he has picked. And then you pick one day of the whole year, but it has no relation to what other people have picked. So each one of you has how many choices? Let's start with you. 365 for you. How about you? 365, because I said don't care, do not mind what other people have picked out, because I want to know the total number of possible ways of people picking one day out of 365 without any concern of being the same or not. Okay? What about you? How many days can you pick from?
I didn't know idea yet. I didn't think you were asking me.
Oh, that's okay. Okay. So the idea is you have to pick one day out of a year. Two people have picked out dates already, but I told you, don't mind, you can pick the same dates or some other days. It doesn't really matter. So how many ways can you pick a day out of a year? 365. Thank you. So each one of you can choose one of 365 days. So now we have n people. So how many ways can these n people choose one day out of 365 with no concerns whatsoever whether a date has been picked out already? Okay, so it's a power thing. So the question now is, which one to the power of which one? What do you think? 365 for you, that's 365 to the power of 1. 365 for you, that's 365 times 365, because you can pick any day and you can pick any of the 365 days, right? So that means 365 times 365. And you can pick a day out of 365 independent to what days have been chosen. So between the first two people, there are 365 squared ways of choosing 2 days out of 365. But the way you're going to choose is independent to that. So that means for each way that these two people can pick, days out of 365, you have 365 choices as well. So that makes it 365 to the power of 3 when we're only talking about 3 people. When we have n people, what are we talking about? Exactly. So when you divide that, you get your chances. Now, what chances are we talking about? Because we have to be sure, what are we talking about? This is the chances of n people choosing unique days in a year. But my question is, what are the chances that... Oh, okay, that's actually was my question. Okay, my question was, what are the chances that everybody in the class have unique birthdays? I think. Okay, but usually it's asked the opposite way because it's more interesting that way, which is, what are the chances that at least 2 people of a class have the same birthday? Okay, all right. So that would just be 1 minus this because it's the exact opposite, right? So I will spell out what that means. So I'll just say that 1 minus this number is the chances that at least 2 people out of n have the same birth date. Okay. All right. So you look at this, and this is pretty abstract, right? Because n, we don't even know what n is. So how does it scale? Okay, that's the question. How does it scale? What happens when n is 1? You have 1 person. So when n is 1, how many ways can you choose one thing out of 365? And ordering is important. Well, when you have one thing, what ordering are we talking about? 365, right? There are only 365 ways to choose one thing. Is everybody convinced about that? Okay. What about 365 to the power of 1? What is that? 365. So it's 365 divided by 365. 1 minus 1 is 0. So given only one person, there's no chance that that there's no chance that at least 2 people out of n or out of 1 have the same birth dates. Okay, let's go for the extreme case of 365 itself. Yeah, 365 itself. So we have the number of permutations of choosing 365 things from 365 divided by 365 to the power of 365. And what do you think that number is going to look like? The question is, which one is going to grow faster? Is the bottom one?
No, factorial is going to grow faster.
Well, the top one becomes 365 factorial, and the bottom one becomes 365 to the power of 365. So yes, the bottom one will still be growing faster. And what do you think that number is going to look like? Is it going to be big or small? 1 minus that. So this portion is going to get pretty small, right? So 1 minus that is going to be almost 1. So it is almost 100% chance that at least 2 people out of n would have the same birthday. Okay? Yep.
Wait, so that mean that if 365 people, does that mean it's possible no one has the same birthday?
Say that one more time.
So if you have 365 people, does that mean there's a chance that people don't have the same birthday? Wouldn't it be like 100% chance that someone share a birthday if it's 365?
What are the chances? It should be 100%.
Yeah, so does that mean it's basically, the second part of the equation is 0 then, right?
It should be a 0 or undefined. Well, we'll take a look at some n values. Yep.
Back to the original question.
Mhm.
Chances that no one shares a birthday. Why would it be 365 to the n power rather than permutations? Because if you're assuming that nobody's going to have the same birthday, like the question is asking, then after the first person picks a day, the next person will want to pick a day that's not that day, so they have one less day to pick from. And then
But that's only in the numerator. That's already taken care of by permutation.
I'm just talking about that no one shares a birthday.
No one shares a
Original
birthday.
question. Given n people, what are the chances no one shares a birthday?
So if no one shares a birthday, it means everybody picked a different date, right? Out of 365. But ordering is important, and that's why we're using permutations.
That's what I'm saying. It would be permutation, right? Maybe for that problem.
It is permutation. That's why I use a P here to represent permutation. Okay, so we have 1 minute left. Let me see if I have one tab of a spreadsheet open. Yep, we do. And I don't even know what this spreadsheet is about. We'll find out. Okay, it's about a certificate thing, It's all right. I can just hijack it for now. It's still loading. Okay, so we'll figure out the numbers. It's working. It's working very hard. There we go. All right, so we have 1, 2, 2, 3, 4. Okay. And then on this side, we have the equation, which is 1 minus the permutation of 365, choose whatever number is in column A, and then the whole thing divided by 365 to the power of the same number here. Okay, so now we can look at the effect of this. It doesn't know that I want this number to be 1 more than the previous number. That will fix that. And okay, shift, drag. There we go. So last time I checked, this class has 50 people. So we'll stop at 50. And the number is 95%, which means, if I take a poll of all the birth dates in this class, there's a 97% chance that at least 2 people in this class have the same birthday. It doesn't seem to make sense, right? Because 50 is only about 1/7 of 365. So it doesn't seem to make sense that it's so close to 100% already. So how would you convince yourself that it really is 97%? How would you convince yourself that is the case? You can write a program, right? Write a program to simulate, people in the class, and you just have to randomly pick, 50 out of 365, and then you have to run the program through, a sorter or some way to see whether those 50 numbers are unique or not. So you basically run this program many iterations, and then you just find the chances by empirically, I should say. Empirically, you can actually run the experiment and see whether it matches the calculated value. So we'll get to that next time, because we have to vacate the classroom for the next class. I like your answers. Short and sweet.
Here's what I was saying.
Yep.
As in the original question, given n people, what are the chances no one shares a birthday? Wouldn't that be the answer?
Nope, because that's not a chance. That is a total. That's a counting. You're answering a counting problem, but not a probability question.
Okay.
So the probability question is, if I walk into a class of 50 people, okay, what are the chances that at least 2 people in the class have the same birthday? So that probability has to be between 0 and 1.
Yeah, I was just talking, but this is for the 2 people sharing a birthday. I was talking
At
about
least
no
2.
one shares a birthday.
So this is for at least 2 people in the class sharing the same birthday.